All right, let's talk about arousals. Arousals can be one of the most disputed characteristics of staging and scoring sleep studies. They can be totally and blatantly obvious, and they can also be incredibly subtle. It's important to know the rules so that you know what an arousal is and is not. The arousal rule in the manual states verbatim: score arousal during the stages N1, N2, N3, or REM if there is an abrupt shift in EEG frequency, including alpha, theta, and/or frequencies greater than 16, but not spindles, that lasts at least 3 seconds with at least 10 seconds of stable sleep preceding the change. Scoring an arousal in REM requires a concurrent increase in submental EMG lasting at least 1 second. So with any arousal, we are looking specifically for the EEG to suddenly and abruptly shift to a different frequency, and a lot of times the frequency will be the patient's PDR. There are a couple kinds of arousals. There are the most common kind, spontaneous arousals, and that's just when you wake up because you wake up, either because your brain says so intrinsically or there's an environmental stimulus that wakes you up. Your brain just says, hey, wake up. The other kinds of arousals are secondary or because of respiratory or movement events. We want to keep those two separate because we want to know how many times the patient woke up because of regular reasons versus how many times the patient woke up because of respiratory or movement events. I personally want to highly and deeply encourage you to practice staging sleep and scoring the arousals as you stage sleep in the 30-second window. Many sleep techs fall into the habit of scoring arousals in a 2-minute window when it's incredibly difficult to see the subtle EEG changes. Also, most software will link the arousal to the event that you score, like an hypopnea, and it'll make the arousal secondary to an event automatically. This becomes important in reports because that's how the software keeps track of why the patient arouses, either spontaneously or secondary. There are additional rules in the manual. The first is regarding the specification of where the arousal occurs. Usually, the sleep study software you use has different places you can score an arousal. It's usually in the occipitals because that's where we're looking for the arousals, mostly for PDR or alpha. The second note says arousal scoring can be improved by the use of additional information in the recording, such as respiratory events and or additional EEG channels. Scoring of arousals, however, cannot be based on this additional information alone, and such information does not modify any of the arousal scoring rules. I like to look at all the channels in a line, starting where I think there's an EEG arousal, a line up and down, right where I think it starts. And I check to see if there are other abrupt changes in any of those other signals. You can use those changes in the other channels to further confirm that there is an arousal, but you can't just score an arousal because the patient had an hypopnea. They have to have a legitimate hypopnea and an arousal. The third note talks about all arousals scored in between lights out and lights on during wake should be counted. You can have 10 seconds of sleep in an epic, but an epic is still staged as wake because the majority of the other 20 seconds is still wake. So that arousal from sleep to wake still counts. The fourth note is kind of the opposite of the third. An arousal has to be 10 seconds of sleep, has to have 10 seconds of sleep before it is to be scored. And this rule says 10 seconds of sleep can occur in a previous epic that may be staged as wake. The final additional note seems pretty similar to the third. If there is an arousal during an epic of wake, score the epic as wake and keep the arousal in. The AASM is not great about explaining things sometimes. Just think about if you had an epic of non-REM 2 and then an epic of about 10 seconds of non-REM 2 and then the rest of the 20 seconds is wake, you can still score that arousal during wake even though it is wake. Sleep staging can change from one stage to another, either from an arousal or from the natural progression of the sleep cycle architecture. If there is no change in the waveforms as far as no arousals or no increased or decreased amplitude, just keep scoring the same stage. For example, if you're scoring N2, keep that going until you see a change either of the waveforms going to N3 or to REM, or if there's an arousal. Like I've said before, sleep onset is the most difficult feature to stage because it can be very subtle. Don't let your brain tell your eyes that you are seeing sleep if there is no evidence. Sometimes alpha or the PDR can look different, but if you're not seeing slower waves, it's still wake. Watching a patient try to fall asleep during a sleep study is like waiting for a pot of water to boil. Here are the different ways staging can go from non-REM. Non-REM 1. An arousal in non-REM 1 does not guarantee an awakening, but it may. Non-REM 1 is the lowest of the sleep stages, so it can't regress into anything other than wake. Remember that stage changes only occur if the other stage represents the majority of the epoch. Non-REM 1 can change into N2 with the presence of K complexes or sleep spindles. Non-REM 1 may change into non-REM 3 if there is sufficient delta wave activity. Non-REM 1 can also shift into REM if there is evidence of low chin tone, sawtooth waves, and REMs. This is a 1 minute screen, so that means there are two 30-second epochs. The first shows some alpha for the opening seconds, and then that alpha begins to attenuate and get smaller. So right here in the O's, this is some alpha. And right here it tries to get a little smaller, and then they wake up right there. So there's also one small wave in the middle around epoch 14 or second 14. Right there. Making that. So I don't know if you can see each of these little green lines is a second, and these bold lines are 5. So 1, 2, 3, 4, 5. It's like that. We have further non-REM 1 with the slow rolling eye movements. That's one right there. Non-REM 1 terminates where that green box is. This is where the arousal is. This software is from Compumetics, and that's what it looks like when you score an arousal. It's that green box. You start it right where you think the arousal is, and here it's right on that alpha. And you just click there on the right, and it'll go on. It's kind of subtle, but that is big alpha, and it's easy to see. The breath underneath the arousal is also a little longer than the previous breaths in non-REM 1. So that's pretty difficult to say, and I keep saying that, but that's what arousals can be like sometimes. There's no big change in the chin tone. The heart rate might get a tiny bit quicker right there, but it's nothing as far as, the wires aren't totally black and moving all over the place. So this is a very slight arousal. Here's another couple epochs from that same study. The first epoch was wake until a little bit after halfway through, and then the alpha attenuates. Here, this patient is in non-REM 1 for about 20 seconds. This is 30 seconds of the epoch. And then attenuated alpha right there. This is non-REM 1 for about 20 seconds. And right there, alpha comes back. You also have the classic eye rollers, slow rolling eye movements. And those go away once the patient has a little bit more deflection in their waves. If you look at the respiration, it lessens, or the breaths are more shallow as they fall asleep. And then the breaths get bigger as they wake up. Here's an example of low amplitude mixed frequency starting out of the epoch. Low amplitude. They're not big waves. There's a little burst of alpha maybe. And then all of a sudden, boom, right there, alpha takes over. That is the PDR alpha. And that alpha lasts about 10 seconds long. If I'm saying that's about halfway right there, so that's 15. And then about halfway of that is about 7, and then it goes away. So I'd say that's about 10 seconds. If I say that's a third of the epic, that's about how you have to think about things, how long things are. You say, well, this looks like about half. Half of 30 is 15. Half of that is 7. So that's about 7 seconds. And it stops right about there. So that's about 10 seconds of alpha. Despite it being a 10-second arousal, this is still non-REM 1 because the beginning half of it is non-REM 1. And then the last 5 seconds is non-REM 1 again. Again, this is kind of tough to see because if you're not really looking for alpha or the PDR, you wouldn't notice, but it shifts immediately from low amplitude mixed frequency to alpha. And there's also no other. It's tough because there's also no leg movements. The heart rate doesn't go up. This patient looks like they're on CPAP. They don't move at all. This is just a very subtle arousal. Oh, what are these funny looking things on those look really sharp. Those waves look really sharp. That's EKG. That is EKG artifact. And that, you can see why that's a problem because it starts to make it look like they're having little waves or sharp waves, which we would consider seizure stuff. So that's why we have the EKG in there with the EEG so that you can tell if that's a real wave or spike or if it's just EKG artifact. We also have the effort here. And you see these little bloops? Bloop, 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 bloop. That belt might be loose, but it's not really. That's just artifact. In fact, a wire might be loose, a battery might be running out. Those little blips are not really doing anything. So, and we'll talk about respiratory later, but sometimes you see little things like that when a patient is starting to obstruct more. Arousals that occur during non-REM 2 may not cause a shift change, may cause an arousal or an awakening, or cause a shift change to non-REM 1. Remember that arousals can be associated with the K complex right before the arousal happens. Don't count those K complexes towards criteria for staging non-REM 2. Non-REM 2 may also give way to REM if the chin tone reduces and REM features appear like rapid eye movements, low amplitude mixed frequency, and sawtooth waves. Here we have N2 because we have some spindles there just before the middle. So right here, those are some spindles. They're a little small. That might be a little tiny spindle right there too. There's some very subtle chin tone if you look past the leg wires. Right there. Those are actually snores. And that's snore artifact showing up. You can see that when the patient arouses right here, and just a little later it looks like an awakening because that's heavy alpha, and it looks like they're waking up a little bit. This might be rolling around artifact. See how it's going this way and that. But the first 15 seconds or so is non-REM 2, and non-REM 2 is enough to stage this as non-REM 2. This is an arousal secondary to a respiratory event. Right here, this looks like an apnea, and then they wake up from it. it's hard to see respiratory events in a 30-second epic. So, uh, when you're staging, you might see that, but it's not important until later. Here's we have what looks like some residual arousal in the waves at the beginning. So I would guess an arousal occurred just before this epic. See how much alpha there is right there, and it's kind of all over the place. We still have some decent waves as well. I mean, these are looks like some good vertex sharp waves. There's a nice spindle and a K complex, and then some lamp, and right there at the 15-second mark, we have a big burst of alpha activity that is coupled with high or more chin tone, and then we have some slow rolling eye movements right after. The respiration looks like it might have something to do with it. There's a tiny snore right there, and we have that little blip. Remember, sometimes those can mean something, and right there, the chest or the abdomen is caving in because the air is not going anywhere, and that creates that snore. The respiration looks like it might, yeah. We'll talk more about flow limitation later. This is still N2 regardless of the 10 seconds of N1 at the end, because this doesn't look like it has any K complexes or sleep spindles after the arousal. But the whole first 15 seconds can be considered N2. This epic starts in non-REM. This montage has the eyes at the top, and then the chin, and then the EEG. The EEG looks like it's got a few slow waves right at the beginning, and there's so much at the beginning you can't see because it's behind those things, but those look like a couple slow waves. Followed by some low amplitude mixed frequency, and then a little spindle. Then we have a couple bigger waves right there. Now what looks like a K complex, and then PDR, this is alpha. This alpha is accompanied by slow rolling eye movements and increased chin tone. Those are all signs of N1. Soon after, we see the alpha starts riding on bigger waves, and it's gone right there. So despite the arousal, you got a K complex there at the end too. So the beginning and the end show N2, so this epic would be staged as N2. Had there not be a K complex at the end, it would have been pretty close to 50-50 split between N2 and N1. It still would have been N2. Also, this K complex is right before the arousal, so this does not qualify towards counting N2. Okay, the eyes are on top here, followed by the chin and the EEG channels. Looks like we have at least one or two K complexes. There's one. This looks like it might be another one right there. And then we have this arousal. That is the really black, thick part. With a little bit of, that's probably them moving or scrunching their face, their scalp. A lot of times that's what we see. And the chin was very low until the arousal happens and we get a moderate increase. This arousal looks like it might take about 10 seconds. This looks like it's in good thirds, like so a third here and a third there. So you got a third of non-REM 1 probably, and then a third of N2. I don't see anything. I don't see anything in the second half that suggests N2. In fact, there are some slow rolling eye movements. So that's N1. But because the other part was N2, I staged it as N2. It's the deeper sleep stage. An arousal in N3 may represent a number of possibilities. It may not cause a shift at all, or it may cause an awakening. It may also cause a shift to N1 or N2. Remember that in order to stage N3, there must be delta waves present for at least 20% of the epoch, otherwise it would be most likely become N2. It may also transition into REM if there is evidence of the lowest chin tone, sawtooth waves, lamp, and rapid eye movements. A lot of the time, stage shifts do involve arousals, even in the progression from non-REM to REM. In that case, REM may shift to N1 in order to go to REM. The EEG is all at the bottom. For this one, we have some nice, decent waves here at the opening. And then after about a third of the epoch goes by, there's a lot of black that happens. This is an arousal. And it looks like there's tension on the wires there too. The darker lines means that's fast frequency, right? It's happening very fast. So this is also muscle twitching. Muscles twitch very fast, so they show up on our screen like a big black blob. This is not a seizure activity. Most seizure activity does not involve or induce movement, like it's widely believed. You think a seizure is going to happen and they're going to tense up. That's not always what happens. Seizure activity can happen, and the patient might not even know it's happening. That kind of stuff looks more like actual waves. They're sharp, but they're not that sharp. Those are very sharp waves. Those are muscle twitches. It looks like they try to fall asleep right here again, but then it looks like the patient does some more movement. That's what all that heavy black stuff is. It may be the case here that the patient has made the wires pulled taut, so that this is tension artifact. If you pull a wire and it's almost coming off of the head, it can make it look like that. I'd also want to look at the video to see if what the patient's doing. Then I would consider, if they were still, then I might consider that sleep. If it's not sleep, then the whole epoch would be staged as wake, because you only have 15 seconds. It's more like 10 seconds. Here's clear and obvious non-REM 3. Look how nice and big and straight lines those waves are. Those are big waves. And then this big old arousal happens. Even if you can't tell, there's PDR, it's right there, though. You can see it a little bit right there. That's the PDR. It's hard to tell where the arousal stops. I would guess somewhere right here, because we have these big old delta waves continue going. It looks like the technologist has witnessed the patient sitting up, and that's why you see them writing sitting up right there. So that extra blackness on the signals are probably tension artifact. When you get excited, well, you might not understand wires like I did. When I got excited playing my original Xbox, when I had to plug in the controllers, and I would get mad or something, I would stand up and the wire would rip out, or it would get really tight. That's the same thing that's happening here, and that's what it looks like when the wires get tight. Here's just about the same thing. Big, slow waves, and then an arousal. And some residual thick lines. The patient is asleep here, but doesn't look as pretty as this does. Here, sometimes wires will catch on something that the patient's wearing, and it'll make this tension happen. The patient may have their hand under their head, and that could be pulling on some wires. It's kind of tough to see what happens after the arousal. Because there's a lot of movement, check out the respiration. There are big changes in the respiration. They've woken up and all that. So luckily we know that this is actually due to a night terror in the notes. The patient is still in slow wave sleep throughout the arousal. So they continue to move around, and they're probably inconsolable here. You'll learn more about sleep terrors in pediatric sleep class. REM may change from an arousal to N1 N2 or N3, although I've not personally seen it in a sleep study, only N1 or N2 really. It may cause an awakening, or it may not cause a stage shift at all. Sometimes there's a period at the end of REM where it just looks like alpha. If nothing else has changed, including the chin tone, keep scoring REM. A lot of times, if N1 is coming after REM, there will be signs like slow rolling eye movements, lamp, maybe vertex sharp waves, and normal chin tone. Remember, an arousal from REM requires at least 1 second of elevated chin tone to score. Here's REM. The top two signals are the eyes. Conjugate eye movements. Conjugate rapid eye movements. Just below that, we have a pretty fine chin tone. And then beneath that are the 6 EEG channels. The first and second sections there show some interesting waves that mimic the EOG. Those are EOG artifact. Remember, in REM, you're not going to have big waves. Those waves probably look like this, but because the eyes are moving, especially, see how it's bigger in the Fs than it is in the Cs or the Os, because the Fs are closest to the eyes, so it'll pick up those movements more. In the fourth line section, we have darkening in the EEG right there, and we have some elevated chin tone right there. And that appears to last several seconds. So here we're looking at 2+ epochs. This looks like 2 epochs to me. But the important thing is, where does the REM go? The chin tone stays elevated, and then it relaxes a little bit at the end, but it doesn't return to the extra fine signal that we saw back here. So it looks like we also have some slow rolling eye movements in the EOG after the arousal. So we might just be going back into non-REM 1. If this continues to get low, 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 then it might be going into REM. And that looks like lamp right there. If I'm looking at this record for the first time, my eyes are drawn to the eyes at the beginning. And those look like rapid eye movements. Right beneath it, I see a very fine line for the chin. Right away, I'm feeling like this is REM. Looking lower, we look like we have lamp right there. And then we have these little waves. It kind of looks like K-complex, doesn't it? But it's happening when an eye movement happens, so that's probably just EOG artifact. You'll have a lot of that in REM. Then in the third section, we have chin elevation. This and a little bit of PDR right there. PDR. It's kind of small. It doesn't have very much amplitude. But this is the PDR as well. And then it kind of attenuates, and we have bigger waves there. Smaller waves into bigger waves. And also, the chin goes back to that nice, fine signal. That looks like it might be an eye movement. I'd really want to see what's coming on after this to call this REM. But just based on this, I'd probably keep the staging of REM because the chin goes down like that so much. And that could be an eye movement. But there looks like there might be an eye movement in the EEG beneath it as well. So, right there. Yeah. So, that's the neat thing about staging. You can consider what would happen in the future, but you don't have that. So, based on what you have, what do you call it? Here's an epoch of REM. It's pretty tough to see the EEG, but the bottom line for REM is that it has to be elevated chin tone, and that's really what I want you to see. There is here, right there. We had a finer line, and we've got the eyes here. There's an eye click. And then, you know what, these look like eye clicks as well, but they're not opposite of each other. What I think happened is I think they've got the eyes either they're both up or they're both down, So sometimes you'll get an eye click that looks normal, and then the other times you'll get this kind of looking thing. Um, so here's a big EEG shift, and there's one, but we can't see it because this program, or it kind of looks like it might have even been. This is computer, I think. I don't think this is paper. This has pin blocking on it, removing the high peaks from signals and the really low troughs. And this is an awakening. Look how much they're moving around. I mean, this whole thing is just covered in signal stuff, right? So this is, remember, the really dark signals in the brain are not brain waves. Those are muscles being tense. Muscle fibers twitch faster and they're greater amplitude. So this is actually a great example of obstructive hypopnea, actually. We'll talk about those in the final episode of this series, scoring events. But yeah, arousals are strange, and but if you have the more evidence you have from the different channels, the more confident you are. So look for the PDR, and if you look very closely, arousal should come fairly easy to you.